Hello, welcome to our presentation. Today we will talk about System BBT Activities Post-Development. Our group is composed by Emily Herzog, Rene Hasu, and Jorge. In this chapter, we will describe a set of BBT activities that typically occur within the system post-development phases, which are production, use maintenance, and disposal. We will provide detailed information for each activity in a standard format that provides a user an easy way to understand the content. Let's start with the activities happening in production. The purpose of this system production phase is to reproduce the complemented system in appropriate quantities. BBT activities during the system production phase intend to verify the quality of the incoming material components and subsystems, validate the production process, and perform ongoing product quality control. The following sections will define specific activities that are appropriate for the system production phase. Let's start with the first activity. Participate in production in functional configuration audit. FCA. The objective is to formally validate that the development of the configuration items, CIs, as well as the completed operation and support document has been completed satisfactorily and that each CI has achieved the performance and functional characteristics as specified in the functional or allocated configuration identification. The inputs are the functional requirements for the system and test or operational data showing how it operates. It's basically composed by 6 steps, which goes from ensuring the availability of the verification matrix, showing the requirements, verification methods, and testing procedure name, add columns to the matrix for test status, review the test results, documentation or inspection analysis, report that are associated with verification for each requirement. Record the appropriate information in the expanded verification matrix. Identify any requirements that are open. Write a report which will document the functional configuration audits and its findings. And finally, resolve any findings and other issues with the project management team. The second activity will be participate in physical configuration audits (PCA). The objective of this physical configuration audit is to technically examine a set of designated CIs and check if each CI as built conforms to the technical documentation which defines it. The inputs the PCA may use, but is unlimited, to data from the following processes and tests: FCA report, physical HWCIs and CSCIs, components, subsystems or system specification, testing and verification reports, programming process plan, configuration management records, deviations and waivers, problems, reports. There is a simple 8-step process that helps the user to emulate this process, which are: Step 1. Gather relevant PCA data and documents. Step 2. Review FCA reports and verify incorporation of actions, items, and findings. Step 3. Review the system and its specification to ensure that the requirements are implemented in the design matches the specification, and the specification match the actual HWCIs. Step 4. Review all systems testing and verification reports and ensure that all design errors that were detected by verification processes were corrected. Step 5. Review the process plan for component programming or otherwise adjust to specific configuration. Ensure that the plan has been followed accordingly to the design specification. Step 6. Review problem reports, deviations and waivers to ensure that there are no open issues with the design of the components or subsystems or system. Step 7. Generate a status report documenting the PCA process and finding of the results. And finally, Step 8. Resolve any open issues and irregular findings with the project. The next step is Plan Systems Production BTT process. The objective here is to plan the system production BTT process at the beginning of the system production cycle. It is described by planning the production BTT process entails formal creation of the production BTT flow, including the identification of required production BTT strategy, schedule, management, and resources. Generate a first article inspection procedure. The objective of this activity is to create an FAA procedure. First article inspection provides objective evidence that all engineering designs and specification requirements are properly understood, accounted for, verified, and documented. So once the inspection has been carried out successfully, system production can commence. Description. The first article inspection refers to actions that are necessary to maintain high quality and verify the features and characteristics of a material process, product, service, or activity to specify requirements. Some of the basic information within the first article inspection document should include product name and number, specification requirements, dimensional measurements, detailed statistical analysis, design characteristics, and easy-to-read customer reports. Validate the production line test equipment. The objective of this activity is to verify the status of the production line test equipment and to calibrate and test the test equipment on a regular basis in order to reduce risk of production line failure. The production line test equipment should be regularly calibrated and validated as part of the production process. The main technical characteristics to be considered for the testing equipment are reliability, maintainability, precision, resistance, and safety. Verify quality of incoming components and subsystems. Objective. The objective of this activity is to verify that incoming materials, like for example, inventory used in the manufacturing process, components or subsystems met specifications before they are embedded into the produced system. Description. Materials, components, and subsystems to be incorporated into a product, example, a system, must be checked before they are integrated into the system, since the system depends strongly on the quality of its work. The objective of checking the received components or subsystems is to verify that they meet the required specification. This activity will reduce costs since faulty systems detected further along the production line will lead to expensive corrective actions. Perform a first article inspection. The objective here is to provide objective evidence that all engineering, design, and specification requirements applicable to the first article manufacturing in a production line are properly understood, accounted for, verified, and well documented. The first article should be produced on production equipment and using process which will be utilized on production lines. Subsequent repeated first article inspections should be conducted following every major tooling or design change and subsequent to any evident quality degradation for a specified specific article, component, subsystem, or system. Validate pre-production process. The objective here of this activity is to guarantee to a reasonable extent the pre-production validation of product and process quality, as well as compliance with national and international regulations. The description is the validation of this pre-production product quality and process must follow a set of rules that emanate from the system specification and sometimes from existing national and international regulations. The intent here is to validate the production system before starting full-scale production. Validate ongoing production process. The objectives of this activity are three. First, continuously monitor and validate the production tools and process. To assess ways and means to reduce production cycle time and cost. And finally, to evaluate on an ongoing basis the manufactured products and systems and to ensure that they fulfill their specified rules. Description. During the production phase, assessments of the production tools, production processes, and resulting products or systems should be undertaken on a continual basis. The intent is to identify faulty products as soon as possible and to improve tooling and process over time. Continual product modification and improvement requires that the production tools and production processes to be updated regularly. In particular, the quality acceptance procedure should be fitted and harmonized before introducing a new version of the product into production. Perform manufacturing quality control. The objective of this activity is to perform manufacturing quality control for all relevant production lines. The description. Basically, manufacturing quality control has traditionally been given associated with measuring various product and process parameters and evaluating these parameters for consistency over time. Verify the production operations strategy. The objective of this activity is to verify the production operations strategy of the manufacturing organization. A production operation strategy is the approach taken by organizations to deploy its resources in order to obtain stated economic and societal goals. The purpose of the BBT actions is to verify the chosen operation strategy in light of the organization's goals. Verify marketing and production forecasting. The objective of this activity is to verify of the marketing and production forecasting of the manufacturing organization. Marketing and production forecasting is a mechanism to predict sales of products and systems and to plan future production operations. The purpose of this BTT actions is to verify that these forecasts are performed under a sound process and produce reliability and accurate results. Verify agreement production plan. The objective of this activity is to verify the aggregate production planning of the manufacturing organization. Aggregate production planning is the process of determining how many products or systems are going to be produced and in what mix, as well as how many employees are needed at each skill level for a given production planning horizon. The purpose of these actions is to verify the aggregate production planning in light of the organization goals and the marketing and production forecast. Verify inventory control operation. The objective of this activity is to verify the inventory control operation of the manufacturing organization. The inventory control is the process of optimizing the quantity of inventory within a manufacturing organization. In general, demands for inventory emanates from customer purchases of end products or systems, as well as the demand for raw materials, lower-level assemblies, and components needed by various manufacturing. Verify supply chain management. The objective of this activity is to verify the supply chain management of the manufacturing organization. Description. Supply chain management might be defined as the management of materials, information, and financial flows in network consisting of producers, manufacturers, distributors, and customers. Supply chain management attempts to optimize the flow of raw materials, products, and systems, as well as information and money between suppliers and manufacturers, within the manufacturing entity, and between manufacturers and customers. Verify production control systems. The objective of this activity is to verify the production control systems of the manufacturing organization. Description. Production control is the approach used by the organization to obtain raw material and components for the manufacturing process, as well as move products and subassemblies within the manufacturing plant. Often, manufacturers select either the MRP requirements, material requirements planning, or just-in-time approaches. Verify production schedule. The objective of this activity is to verify the production scheduling of the manufacturing organization. The production scheduling is concerned with sequencing activities within a plant or a job shop. The purpose of these actions is to verify that the production scheduling is optimally efficient in light of the production forecast. Participate in production readiness. The objective of the PRR is to determine the status of the specific actions that must be satisfactorily accomplished prior to undertaking a production go-ahead decision. The PRR is often the last checkpoint before full-rate production is initiated. The PRR is concerned with the gross level manufacturing issues, such as need for identifying high-risk or low-yield manufacturing processes or materials, or any specific requirements for manufacturing development efforts to satisfy design requirements.
The use and maintenance phase of a system lifecycle is the time when the system is actually in use and operating in the intended environment. It is usually the longest lifecycle phase. There are 4 main activities for this phase. The first is developing the VVT plan for system maintenance, which involves deciding what maintenance activities will be performed and when. The second is verifying the Integrated Logistics Support Plan, or ILSP. The ILSP identifies what support elements are needed for maintenance. The third activity is performing the ongoing system maintenance testing, which seeks to optimize the system availability and perform maintenance in the most effective way. The last activity is conducting an engineering peer review on the system maintenance process. This involves analyzing the maintenance process and its effectiveness and looking for possible improvements. Once again, the use and maintenance phase is usually the longest life cycle phase and will need a great amount of planning. Planning the maintenance will help sustain the system in a working condition, facilitate any future modifications, and leave room for updates and improvements. The system's maintenance concepts should be developed early in the planning process. The maintenance concept addresses the proper use of the system and the procedures operators, as well as maintenance staff, will follow when interacting with the system. The concept also considers the anticipated lifespan of the system, which may be based on previous experience within the team or comparisons with similar systems. The environment the system will be in should also be considered because that will affect lifespan and maintenance procedures. The environment may also introduce additional stresses into the system. Policies on how to perform different types of repairs should also be decided. Simulations may also be conducted in order to help predict some of the behavior of the system. There are several different types of maintenance that can be performed on a system. Emergency maintenance is unscheduled maintenance that occurs when something unexpectedly goes wrong in the system. It is categorized into production issues and pressing issues. Production issues are urgent work that stops a system's operations and therefore has to be addressed as soon as possible. Because of their time-sensitive nature, these issues are often fixed without full VVT attention. This can lead to a reduced quality assurance. Pressing issues are urgent work that impacts operations but does not stop them completely. Pressing issues can be addressed while the system is still operational, meaning that they are not as urgent as production issues. Since they can be addressed while the system is still running, there is often more time to perform a more thorough VVT process. Corrective maintenance identifies and removes non-critical system defects. Perfective maintenance is used to upgrade the system in some way instead of fixing a defect. Adaptive maintenance modifies the system in order to keep it up to date with the environment, which could be new regulations or a new software system. Preventative maintenance identifies and replaces system elements that will cause errors in the future. Proper preventative maintenance can reduce or even eliminate the need for most emergency maintenance activities. The cost is also an important consideration when planning the maintenance of a system. Maintenance is often perceived as something that only happens when something breaks, but studies have shown that this is not always true. Over the years, studies have shown that emergency and corrective maintenance only makes up about 20% of the total cost. The rest of the resources are used towards preventing failures and improving the system. There is also evidence that frequent minor maintenance is more cost-effective than infrequent major maintenance. It is cheaper to prevent major failures, even if that means performing maintenance more often. There are often obstacles to performing maintenance on an operational system. The first is planning. Maintenance is often seen as several separate tasks rather than a single process. All maintenance activities should be planned in advance and coordinated with the operation schedule in order to prevent any conflicts. Maintenance and operational conflicts can happen when regular maintenance interferes with normal system operations. This can be avoided with flexible planning as well as an understanding of what maintenance activities are incompatible with certain operations. Configuration management should also keep up with any maintenance activities being performed. Generally, there are 3 system configurations associated with a system undergoing maintenance: the existing configuration before any changes, the temporary configuration used during testing and modification, and the final configuration. The logistics of a system may also change with any maintenance or modifications. It is important to update the logistics requirements as changes are made to the system. Legacy systems or older systems may not have as much information available about them to use in planning. They may also have components that are no longer available and therefore may be difficult or impossible to replace. The VVT team needs to analyze legacy systems carefully and find any possible problems as early as possible. The VVT engineer needs to monitor the system's behavior throughout the use and maintenance phase of the lifecycle. Specifically, the VVT engineer must evaluate the system before and after maintenance to make sure that no defects were introduced into the system during maintenance. The Integrated Logistics Support Plan, or ILSP, defines the support system that the system will need when undergoing maintenance. The ILSP identifies support elements, management objectives, maintenance tasks, and equipment needed during maintenance. It will also outline any outside resources needed for maintenance in order to facilitate planning. Performing the maintenance testing involves carrying out the activities needed to sustain a system. As mentioned before, maintenance is generally divided into two types: preventative and corrective maintenance. Preventative maintenance testing is inspecting the system and making sure it performs according to expectations on a day-to-day basis. Corrective maintenance is conducted when a system malfunctions or fails. The first objective of maintenance activities is to minimize the overall cost of maintenance by utilizing preventative rather than corrective maintenance. The second objective is to find the most effective way to make the repairs as quickly and cheaply as possible. The third objective is to optimize repair or replace strategy in order to save the most time or money. This means recognizing when it is worth the time and effort to repair an element, or if it would be more cost and time effective to just replace it. As mentioned before, when planning and organizing maintenance, the overall maintenance concept should be considered. This means defining an overall goal for testing and validating the system. The test and support equipment, as well as their requirements, must also be defined. You must also list all of the system elements that may require testing. A general description of the personnel needed to perform maintenance and testing should also be provided, as well as the training requirements for these personnel. Any software that is included in the system must also have its testing and maintenance requirements defined. As mentioned before, when carrying out maintenance, preventable maintenance needs to be performed on a predefined schedule that is compatible with planned operations. Corrective maintenance shall be performed whenever it is needed and will comply with the predefined policies or requirements. A peer review should be conducted periodically in order to verify the effectiveness of the maintenance process and identify any areas that could be improved.
Hello, my name is Rene Hassel. I'll be covering the activities or what we should do during a disposal of a system and its elements upon completion of its life. During this phase, systems should be pulled apart or dismantled, partially or completely recycled and shredded. Finally, toxic materials must be neutralized. Many systems have no formal disposal requirements, but dangerous materials should have specific disposal requirements related to environmental protection. Verification, validation, and testing activities during the system disposal phase include developing a VVT plan for system disposal, assessing the planning of the system disposal process, assessing system disposal plans by means of simulation, as well as assessing the ongoing system disposal process, and finally, conducting engineering peer review to assess the system disposal processes. I will now go over each of these activities in more detail. The first activity is the development of a VVT plan for system disposal. The objective of this activity is to develop a VVT plan for the system disposal phase. A VVT disposal program management plan is a document used to organize the VVT activities during the disposal phase that supports guidance of the program's execution and control from the VVT point of view. The next activity is assess the system disposal plan. The objective of this activity is to assess the system's disposal process plan, notwithstanding safety, environmental, and economic matters, as well as pertinent legal considerations. The majority of fielded systems have a few, if any, requirements associated with disposal. Most often, the components are removed, transported to various disposal locations, and discarded. Another activity is the assessment of the system disposal strategies by means of simulation. The objective of system disposal simulation is to assess the environmental effects and the level of recyclability associated to different disposal solutions available. Eventually, an optimal disposal strategy is identified, and the optimality of this strategy is assessed during this activity. Simulation approaches may be used in order to measure whether it's the best system disposal strategy. The benefit of this approach stems from the fact that under simulated conditions, the input parameters can be easily adjusted, whereas physical evaluation of different disposal strategies is very complex, time-consuming, and sometimes dangerous. The next activity is assess ongoing system disposal process. The objective of this activity is to verify that the ongoing system disposal process is performed according to applicable environmental and health regulations and policies. This objective includes verifying that the remains of the system do not contain damaging substances to the environment, the disposal process does not constitute any health risk to persons involved in the process, and that the economic maximization of the remaining value of obsolete systems by recycling usable components and salvaging exploitable materials. The enormous number of disposable systems every year generate massive amounts of hazardous waste. The last activity is the conducting engineering peer review to assess the system. The objective of this last activity is to use engineering peer review to assess whether the ongoing system disposal process is done in accordance with the system disposal process plan and according to valid environmental and health regulations and policies. Engineering peer review may be used to assess a system disposal process, and it is actually performed and should be an ongoing verification process conducted throughout the system disposal phase. The basis for the peer review should be the system's disposal process plan as well as the appropriate documents summarizing the ongoing disposal process. For example, certificates of disposal or disposal audit trails. This concludes the overview on the different activities during a disposal of a system and its elements upon completion of its life.